Welcome, scholars, to Mr. Honeycutt's math class. We're going to look at the shape of the tangent function, why it makes the shape that it does. Remember that the tangent function is really the sine function in the numerator and the cosine function in the denominator, because it's the slope of the angle where the sine is the y, the cosine is the x. It's the change in y over the change in x, which is slope. Okay, and compared to the center point, which is 0. So basically it's like sine minus 0 over cosine minus 0 gets you the slope. So then looking at the x-intercepts of sine, well, that's going to be, hey, here's sine. So there's an x-intercept at 0, 1 at pi, and 1 at 2 pi. So that's going to be, the x-intercept of sine is going to be 0, pi, and 2 pi, which means because this is in the numerator, sine is in the numerator, that the x-intercepts of tangent are going to be 0, pi, and 2 pi. So let's plot those x-intercepts. Here's one, and here's one, and here's one. Now let's look at the x-intercepts of cosine. Here's one, and at negative pi over 2, then there was that one at pi over 2, there's another one at 3 pi over 2, and one at 5 pi over 2. So negative pi over 2, pi over 2, 3 pi over 2, and 5 pi over 2. Since the cosine is in the denominator, once we put that cosine, once that cosine is equal to 0, that's going to create vertical asymptotes. So what are the vertical asymptotes? Well, hey, it's going to be x equals, remember vertical asymptotes have to be x equals lines, x equals pi over 2, negative pi over 2, pi over 2, 3 pi over 2, and 5 pi over 2. I'm going to draw those now. That's an ugly vertical asymptote. So we can also just straight up divide these to figure out what's going on here. I'm going to draw this in green. So for my tangent function, remember it's sine over cosine. So we just, notice I put this so that this is, you could just divide the numerator and the denominator. So negative 1 divided by 0, hey, that's a vertical asymptote. 0.866 divided by a negative 0.866 divided by 5 is going to be a negative 1.73. Just going to plot that. It's going to be somewhere over here. All right, negative pi over 4. The sine is negative 707. The cosine is a positive 707. Hey, that's just going to make, if I divide those, that's going to be, these are the same, right? So they're going to cancel out. So, hey, that's just going to be negative 1 at the pi over 4s. At negative pi over 6, that's negative 5 over positive 8.66. That's going to be a negative 0.577. So that's going to be somewhere around here. 0 divided by 1 is just going to be 0. And then this is going to be a positive 0.577 for the pi over 6. This will be a positive 1. Again, notice this is a positive 0.707 divided by a 0.707. So those divide out. And it just simplifies to 1. And then you've got a 0.866. So that's going to be a positive 1.73. So plotting those points, it's going to be somewhere around here, come on, and here, and then the 1.7 will be somewhere around there. If I continue, that's just from unit circle values, and if I continue sketching, it's going to look like this. Okay, filling kind of in those dots. We can continue on here, so this is again going to be a vertical asymptote. This will be a negative 1, this is a 0, this is a positive 1, this is a vertical asymptote, -1, 0, +1, vertical. All right, moving along to the inverse tangent. So the first thing is we're going to switch our x's and y's. So does tangent pass the horizontal line test, the original tangent? And the original one does not. That's why we have this piece. When we have just one piece of the tangent, one period, if you will, that piece does. And that's what we're going to actually invert. Remember that the range of the original becomes the domain of the inverse. So the domain of inverse tangent is going to be all reals. And then the vertical asymptotes are going to become the horizontal asymptotes of the inverse tangent function. So looking at some plotted points, there'd be one here at 1 and pi over 4, and at -1 and negative pi over 4. It's going to look something like this. All right. Normally, if we were in class, we would do this with patty paper. So notice that the range is going to be negative pi over 2 to positive pi over 2. Again, remembering this is not a point, it's an interval. Notice these are parentheses. It's an open interval because it doesn't actually touch the asymptotes. There are horizontal asymptotes at y equals negative pi over 2 and y equals positive pi over 2. Funny thing about horizontal asymptotes, you can have as many vertical asymptotes as you want, but it's actually only possible to have up to 2 horizontal asymptotes, one for the left end and one for the right end behavior of a function, which is interesting. It is increasing for all reals, and it's not decreasing or anything like that. It doesn't have max or mins or anything. The arctan function, notice it looks, it's sort of similar to the sine function. I do also want to point out, because it does look quite similar to the cubic function, but the cubic function, remember, goes vertical, or the inverse cube, the cube root goes vertical here, whereas the cube function goes horizontal here. Notice that the slope here, we're going to learn in calculus, the slope is actually 1 here. Is 1, so it's nice, and which is diagonal. All right. So that's a really easy, honestly, like that's how I tell the difference, is I just kind of look at this. Is it a diagonal slope? Okay, then it's arctan. All right, if it goes flat here, that's the one, that's how I know it's the x cubed graph. Now, I mean, those are like basically, the arctan function is a surprisingly useful function. It shows up, really, it shows up in very strange places in calculus. Yeah, oftentimes when you least expect it, that's when the arctan function, and it'll actually come in and save the day. There are these like really hard calculus problems you can't do, and then all of a sudden you can do them with arctan, which is nice. So that's part of why it's useful and why I think you should learn it. So, but these are some of the basic mathematical models that we're using. That's all of them for this, and you should be able to like use all these, understand, again, don't just memorize the pictures, understand why the pictures are doing what they're doing, understand the concepts. Great. Thank you very much. Hope this was helpful.